Okay, let us see the pre-order traversing, pre-order, post-order. Okay, generally these are used to traverse a tree, generally for switching and sorting algorithms. These would be our if you study the academics, most of the times this pre-order, post-order would be useful. See how the CPU calculates a particular expression. Let's say you have a 6 plus 4 plus 3 plus 2, like that. There is an expression. How does the CPU calculate it? So it uses this pre-order, post-order algorithms inside it. Getting my point, right? So these traversal algorithms are used. They were implemented inside a CPU for as part of system programming. What they will do, you take any compiler. So what they will do, if you pass any expression, it will be calculated based on either pre-order or post-order, any traversal algorithms. Okay, I'm going to explain this pre-order tree traversal. You can see, first we are going to create a node. Okay, it should have attributes int space item, and node item means it is the value, actual value. What is the item? And node means tree, so it will have both left and right. Okay, and you can see it is going to have a constructor. It is taking a key value, and we are assigning the key to item value and actual value. Left, right nodes are going to be assigned with a null. Now we are going to build a tree, and tree will have a node. Initially we are declaring a root node, and for root node initially we are assigning it as a null in constructor, and pre-order function is there. Inside that we are passing a node object. If node is null, and we are returning it. In case if it is having any data, okay, passing a data, then we are calling node.item. We are printing the particular item. Okay, and then first we need to, if it is the pre-order traversal, always you need to traverse through the left hand section of the tree. Okay, tree branch. So the tree branch will have left hand section but right hand sections. You need to traverse through the left hand section. Okay, that is why we are calling the pre-order. We are calling the function. You see, it is the function calling itself. Okay, reverse mechanism here. We are passing pre-order of node.left, and after that we are passing node.right. So if you pass all these values, what it will do, it will print like this. These values first, node value is the 1 because you are passing a 1 value. Next you need to navigate to the next. What is the next value? It is the 12. So you are constructing the pre-order tree, pre-order traversal of tree. Okay, so this is how it will happen. Tree traversal mechanisms. Okay, generally binary tree implementation. So these algorithms are generally used in for calculating the expressions and all. Pre-order, post-order, in-order. Okay, these things are there. You can see 157, 158, 159. So let us see the post-order. Post-order, I think it is what is the post-order? Post-order, so post-order means first it will, you can see it will come in a reverse order. First it will traverse through the left hand section of the branch, but in reverse order. You can see what is the value here. The utmost value, the lower value is the 5, and after that 6. First you take the value left side and the right side value. We are coming from bottom up approach. You can see it is not top down here. It is the post order. 5 is the value, 6, and after that root value. Okay, root value. So it will be 5, 6, 12, and 12 is also again left side value, so we need to jump for a right side value. It is a 9, after that root value. So we need to implement, you can see the same structure, but here we are calling post order of node dot left, post order of node dot right. These are algorithms. Okay, I don't want to jump into them. Graph data structure 164. What it is doing here? You see, we have a graph. So you can actually create a graph. Okay, for a graph you need to have edges and elements, right? How many edges are there, how many vertices are there? For a graph you can see how many 5 vertices are there, and edges, you can take the edges, the required edges you want to connect. Okay, so vertices and edges, what do we have through constructor? We have an inner class, edge class, so it will have SRC and destination, source and destination. For every edge you need to have a source and destination, and array to store all the edges. Okay, we are taking some array, and you see graph of through constructor we are actually assigning vertices and edges, okay, integer values. So after that we are creating edge using edges, okay, and we need to initialize the edge array. Okay, how many edges are there? Okay, we need to initialize the array because edge is an array. Now we are iterating through edges and we are creating an edge array. How many arrays will be there? We are going to create that edges, and after that you can see here how you can map. There are number of vertices are 5, and we have a total 5 edges, and you want to derive a graph. How do you do that? You can see that first edge, okay, for a graph, first index of 0, the source is 1 and the destination is 2. So you jump to the graph, source is 1, destination 2, you are deriving a graph. So this is a pictorial represent, but in actual output will be like this: 1-2, 1-3. You specify that it is just a graph. Okay. So using a program you can do anything, whatever you want to do. Okay. These are some examples. Hope this would be useful for you, and thank you.